Hello and welcome to the C++ 102 live online class from 3dbuzz.com. Tonight, your lead instructor will be Mr. Nelson LeKay. Say hi, Nelson.
Hey.
All right. Also joining us, we've got Mr. Gavin.
Hello, Mr. Jason.
Hello, and myself, Jason Busby. So, yeah, C++ 102 class. First of all, let's talk about prerequisites. Hopefully, you've been through C++ 101 that we provided last term. If you did not go through the 101 class, please make sure you have some knowledge of C++. If you do not, you're going to end up running into a brick wall at about 100 miles an hour. That results in very bad things. One thing that we will not be able to do during this live class is stop and spend a tremendous amount of time helping people that decided to skip 101 and just jump right into 102 with no prior knowledge. You will get lost. So if that is the case, you know, we welcome you to stay with us and to watch, try to focus the best you can. And after the class and between classes, please try to watch 101 and get yourself caught up to speed. Now, Gavin is our primary TA, teaching assistant. He will be grading all of your homework. He will also be chiming in as kind of a student's voice and asking additional questions and things to reinforce what is being said by Nelson. Of course, you guys are also free to be asking as many questions as you would like. But as far as questions go, if you want them answered by us, please make sure to place them over in the webinar questions panel. That way they will get answered by us. If you put them in BuzzNet, that is no guarantee that we will be answering them, though there are students over there that I know that have plenty of C++ experience and just love hanging out and helping us, so they will be most likely answering questions over there for you. So you can put them there, just don't expect us to be constantly monitoring what's going on in BuzzNet. And speaking of BuzzNet, for those of you that are in the webinar now, but you are not in BuzzNet, please open a browser and point it to buzznet.3dbuzz.com. Again, that's buzznet.3dbuzz.com. You will need to log on with your regular 3dbuzz forum credentials. And once you get logged on, just go into the C++ 102 classroom. This is important. We are not kicking people tonight, but we will be kicking and banning people that do not use this starting on the next class. Since this is the very first night of the 102 class, we will not be reinforcing it. But it is, or enforcing, excuse me, but it is extremely important. It's one of those things that it's a rule that you've got to follow. It's an important one. We use the system for monitoring, participation, attendance, and all that good stuff. So make sure that you get over there. Now, for the certificate for this class, what is required is 50% attendance and completion of homework to a satisfactory level. If you fail any homework, Gavin will let you know that you failed. You can fix what you have failed and resubmit it. It is not the end of the world. But if you fail something, please don't wait until suddenly, all 8 weeks of this class is over and then turn around and say, hey, here's my homework. That's not good. You need to immediately get on it, get it fixed, and get it sent back in. So as far as the 50% attendance, that means we've got 8 weeks. 4 of those classes you need to be involved in. You do not have to be here at the start of class. You do not have to stay the entire time during class. You just need to make an appearance for, 15, 20 minutes or so. I understand that the time in which we are presenting this class is not convenient for some of you. I apologize. Unfortunately, we do have members from around the world, and we are not all on one standardized central time, unfortunately. So, we do rotate these classes around C++ 101. Last time was held during the 3 p.m. Central Time. We also had one on Friday, but this time around, since we are doing more classes, we had to push this one to Friday at 7. So, wow, it's 10 a.m. where you're at. That's impressive, Atomizer. Wow. Anyways,
yes.
Go ahead.
Sigmund's on his way, for those of you who are wondering.
Oh, okay. Well, that's excellent. Segfault's almost another TA, really. He does an amazing job over in
he's great.
BuzzNet. Yeah, helping people. So he's definitely great. So, Nelson, let's turn our attention to you, my friend. Tell us, what are we in store for in the 102 class?
Stuff. Lots of C++.
Oh, that sounds pretty
What?
cool.
No things?
The what?
I said, what? No things to go with the stuff?
Well, yes. No, the things are, we're going to be putting together a game. We're going to be talking about some fun C++ features. We're going to be talking about a little bit of design, not to a massive degree, but to the extent that it will facilitate us putting together a game. Yeah, I mean, that's pretty much the goal of this class, to help people use the sort of fundamental knowledge that you guys learned during the 101 class and actually apply it to doing something relatively complex and fairly interesting.
Awesome.
So, are you going to be any more specific than that, or not?
Well, it's still going to be in the console. It's going to be a Evil Monkey style game. For those who are familiar with Evil Monkeys, for those who are not, basically a top-down, shooting game. We're going to be doing, looking at putting that together, as far as the code's concerned, to get the engine working and stuff like that, but also as far as the design of the program, so that we can introduce stuff like polymorphic weapon types, polymorphic items, lots of fun stuff.
Awesome. Now tonight, you've got a special night planned. What do you got?
Yeah, we're not going to be. So to everybody listening, we're not going to be going over the main overarching game until week 3, but tonight what we're going to be putting together is a basic tic-tac-toe game. The way that this is going to be organized is we are going to be covering a couple of new features in the C++ language that sort of fell out of place and are simple enough to describe in a short amount of time. And those features that we're going to be using constantly throughout the course. Then we're going to move on. I'm going to be putting together a basic tic-tac-toe game without a rules engine. So the idea is that people will be able to follow along, and they will be able to sort of gauge to what extent they are comfortable with C++, because everything, with the exception of the 2 things we will be covering tonight, has already been covered in previous classes. And then for homework, it will be putting together a rules engine for the game.
Cool. So what are the 2 broad subjects that we're going to be covering tonight that we haven't previously?
We're going to be looking at references and initialization lists. So, yeah.
Cool.
So is there templates and inline assembly? Yeah. Templates, no templates until 103. I'm sorry. So yeah, so was there anything else that you guys wanted to add before we jumped into the class?
No, we've got a lot to do tonight. I will throw this out real quick, and that is, for those of you that are joining us for the first time in one of our live classes, I have to give the webinar system a time frame in which the webinar will proceed through, and of course I always give it 2 hours. Please keep in mind it's rare that our classes end on the 2-hour mark. We have gotten better at it, but the bottom line is we want to make sure that we get the information that we want to teach across to you. These lessons are recorded, they get encoded, and they get put up on 3D Buzz for you to go back and rewatch later, or watch if you did not have the opportunity to see it the first time. So if you have to leave because it's getting really late, don't worry, just leave. It's no big deal. You can come back and watch the video once it gets put up on the system. So I just wanted to throw that out so no one starts freaking out once we pass the 2-hour mark. Okay, over to you, Nelson. Let's get it started.
Alrighty. So we are going to be doing the class primarily in Visual C++ 2010 Express.
And while you're waiting for that to come up, I do want to answer Oscar's question real quick. And he said, can we watch the webinar but not participate? Like not write code along so-and-so and all that good stuff and still pass the class. Yes, absolutely. I understand that for some of you it's 2 in the morning, some of you it's 10 o'clock in the morning, which is crazy. You can follow along. You're getting the lecture right now. The fact that you're in class is fantastic. And then you can do the homework and make sure you get the homework submitted. The attendance and the homework submission and passing the homework, that's all that's required.
Some of us just haven't got enough monitor space in order to have everything open at once.
Yeah, no kidding.
I was trying to follow along with the Unity one, and there are too many windows.
Yeah. Well, not everybody has, you know, a million monitors, Nelson.
No, you had a million monitors.
So you're about to say, so who knows what the output of this program is?
Yeah. If there are any questions about the code on the screen right now, I highly suggest you go back.
Please leave. Yes.
Okay, so what we're going to be talking about are references. Did I make an empty project? I did not. I made a console project. I went to New Project, selected a console project, and made that. And I told it not to add anything else. As you'll notice, there's nothing else other than main.cpp. This is the same format that we've been doing classes in C++ forever. Okay, so we're going to be talking about references. So what are references? Basically, a reference is it's a similar concept to a pointer. So I hope everybody is familiar with, you know, we can have an int number, and then we can have an int pointer, number pointer equals, oh great, at number. And then we can say cout dereference number pointer. Again, I hope everybody is more or less familiar with what this code does. But there's a lot of problems with pointers that are introduced. Pointers have been around since C, and when C++ was designed, they wanted the idea of a pointer, but they wanted to limit it. The reason they wanted to limit the functionality of a pointer was because pointers allow you to do stupid things. For example, I could do something like that, where now I'm pointing to some random bit of memory. I can do something like this, where dereferencing would cause an exception. And that's all valid C++ code. So the designer of C++ wanted to make a concept of a pointer, the ability to point to something else, for a lot of reasons. The biggest reason is performance. For example, if we have let's say we have a string, and we have a function that takes in a string. So here's our nice little function. We have a function that takes in a string, stuff like that, and we can have a string bleh equals hey print string bleh. Now people used to C# know that in C# strings are reference types, and this code does not look bad. It doesn't raise any red flags. It looks like it's a very straightforward concept. But in reality, what's going on here is we are having a copy of our string bleh being copied into the string str on the print string function. Now, especially the larger the data type that you have, the more this becomes a problem, where you are going to incur a lot of performance issues. Now, you could resolve this issue by using a pointer, for example, but using a pointer introduces even more issues. The issues that I talked about before, being able to pass in null, being able to reference bits of memory that should never be referenced. We also have a lot of syntactic noise, where we have to annotate our dereferencing operation on line 7 with the asterisk, and we also have to annotate the object we're passing in with an ampersand. So references are all about getting rid of the issues of safety with pointers, but also introducing a bit of syntax that will accomplish the same thing as pointers, but without introducing a lot of syntactic overhead. So a more correct version of this function would look like this. So you'll notice the differences. First of all, what we have here is the parameter is a reference. And we know it's a reference because the ampersand is right after the type. And the ampersand annotation after a type indicates that this is a reference type. Remember, we can annotate our types with a variety of different symbols to accomplish different things. We can annotate them with the asterisk for making it be a pointer. We can annotate it with the ampersand to make it be a reference. We can annotate it with the square brackets for making it be array. And this is just another bit of syntax that allows us to annotate existing types. So what we have here is the stir parameter is in fact of type string reference. And we know it's of type string reference because, well, the ampersand is immediately after the type string. Just as we know that in this case, this stir parameter is of type string pointer because the asterisk follows the type.
And this goes back to, for those of you who were in the 101 class, and me being pedantic about spacing. And because the one thing is, don't confuse the ampersand on line 10 with the ampersand on line 19. They are two different things.
Yeah. And that's definitely a good point to make as far as C++ in general. There are a lot of symbols in the C++ language, and there are a lot of different contexts that those symbols can be used, and they are reused between different situations. For example, we already had a long discussion about how this asterisk annotates the type, whereas this asterisk dereferences an object or a pointer. So in this case, this ampersand denotes that this is a reference type, whereas this ampersand results in retrieving the address of this object. So first example is... Yeah?
I was about to do that.
So first example is C and second example is C++. Yes and no. They're both C++. Remember, C++ is backwards compatible with C, which is one of the awesome things about C++, and is also one of the most horrible things about C++, is that they had to introduce or maintain the ability to do all the weird esoteric things you can do in the C language when creating the C++ language. But I want to point out that strings or references do not replace pointers. So let's talk a little bit more about references, because I just want to say that we'll talk a little bit more about how references don't replace pointers. But so what a reference is all it is it's like a pointer but with limitations. There are many limitations with a reference. The most important limitation of a reference is that it cannot be changed. Actually, I want to for everybody who's paying attention, I'm going to go ahead and move this code into a notepad window off screen, and then I'm going to write up a piece of code and see if people can guess the output to it. Remember, references cannot be changed. So if you have one reference pointing to one object and you point the reference to the other object, that can't change. So let's go ahead and do int number 1 equals 10, int number 2 equals 20, and then int number ref, or int reference number ref equals number 1, number ref equals number 2. Now if I see out number 1, new line, number 2, new line, number ref, what is the output to this program? And why? Think about it. I did just say you can't do that. Any guesses?
Is that Segfault's guess? That the output's going to be, would you like a nice game of chess?
Okay, this is the most important thing to understand about references. That they cannot change, but you can make the code look like they might be able to change. What is going on right now is that we are going to get, and I just want to prove it to all of you guys, 20, 20, 20. Here's why. When we assign the reference number ref to number 1, number ref is now essentially a pointer to number 1. So number ref is now pointing to number 1. When we say number ref equals number 2, what we're doing is we're taking the value of number ref and we're setting that to the value of number 2, which means now number 1 equals 20 and number 2 equals 20, and because number ref is still pointing to number 1, number ref equals 20. This is one of the nice things and one of the horrible things about references. With pointers, you have a lot of additional syntactic noise where you have to explicitly say things about what you're intending to do. Are you intending to dereference? Are you intending to get the address? But in this case, these two lines fundamentally mean a different thing, even though they're using the same operators, the assignment operator, and they're not annotated at all with symbols. Because this is in an initialization of a reference, This means we are initializing this reference to point to this this thing, this int.
It's almost like, it seems to me like it's almost like a define. Do you know what I mean? Conceptually, you're saying let this symbol represent, in this case number ref, represent number 1.
Right.
Or am I missing something?
Well, yeah, and the important thing to take away is that these are just different bits of syntax. Different operators. Well, not different operators. We're still using the same operator, but they do fundamentally different things. Because after the initialization of a reference, the reference can no longer change. If you ever do reference equals blah, this is an assignment. This is saying take this thing and stuff it wherever this thing is pointing to. It's as if we did this. Or, well, obviously this isn't gonna... Or what am I doing? Help, I'm going insane. Okay, it's as if we did that. So this bit is equivalent to this bit, at least this bit's with references and this bit's with pointers. Now, the good thing about this, there's less syntactic noise. The good thing about this is more explicit. We know exactly what's going on. We know that we're setting number pointer to equal the address of number 1. We know that we're setting the value of number 2 to the value of number pointer. So I just wanted to point that out because that's a very big stumbling block of references. Another consequence of references, because you cannot assign them to null and you cannot reference or have them have what they're pointing to change, you must always initialize them. For example, this would be a compiler error. It says number reference must be initialized.
Were you, I hope you were planning to cover just how these aren't the same things as referencing in C#, because to be honest, I'm still confused on that.
Right. Well, in C#, and I know there's a lot of C# developers out there, you're very, very used to the word reference. And I remember early in 101 when we talked about pointers, people are like, oh, pointers are just like references in C#. I wanted to discourage that because there is something in C++ called references. And C# references are like a mix between C++ pointers and C++ references. For example, C# references can be reassigned, they can be set to null, but they cannot be set to point to random bits of memory. A C# reference must always, whenever you assign it to something, it must always be set to null or a valid object reference. Those are the only two options you have in C#. In C++, you have two things to represent the same thing. You have pointers, which you can point to literally anything. It doesn't matter. You can point to invalid bits of memory, you can point to valid bits of memory, you can point to protected operating system memory, although you get an access violation. So you have that flexibility, but you also have the ability to put yourself in a situation where you're pointing to something that's invalid. Whereas with C++ references, a C++ reference can never point to something invalid, but it's less flexible than a C# reference because you cannot reassign it.
Cool. There was a question in from Joseph and one that's just come in from Jeff as well.
Can symbols be type defed as not to use symbols over again? We haven't really talked about type defs. We'll be talking about those. They can be, but I highly discourage using type defs for pointer values, or pointer types or reference types. Because what are your options? I mean, you're going to type def something int pointer. You're going to type def it to int ptr. I mean, it takes more characters to type out int ptr than it does to type in int asterisk.
Plus, you'll then have to document your code more closely for anyone else to,
understand it.
You're inventing new. You're reinventing the wheel in some ways by doing that.
Right. Using the symbols will always be more succinct. Now, that's not to say that type defs are not useful. They certainly are, especially in metaprogramming. But their use as far as hiding the symbols, I discourage that. And yes, the Win32 API does do that all the time, like LP strwzp5210. Can't stand those type defs.
Jeff did bring up a good point. He said, if there's no way to assign null to the reference, then how do you clean the reference?
There's no cleansing of references. Keep in mind, are you coming from a C# background? Because in C++, memory allocation is deterministic, whereas so that dereferencing something isn't going to cause some garbage collector to come and collect that memory. In C++, you have to explicitly collect memory. So dereferencing a reference doesn't mean anything in C++, whereas it does in C#, because in C#, the garbage collector will only collect memory that isn't being referenced. So it is a good idea to dereference things that you're no longer using, so the garbage collector can come along and do that for you, or to clean up the memory for you. But in C++, since there is no garbage collector, dereferencing is there's no reason to do that. The reference can be applied to all of the types. Yes, you can have a reference of anything that you want. Okay, so getting back to the previous example, because I didn't want to talk about that, but getting back to the previous example, what we have here are two ways of doing the same thing. For methods like, or functions like this, or methods like this that accept things like strings, I much prefer to use references in this case. Now, that's because the syntax is a lot cleaner, and it gives me some level of comfort knowing that whoever passes anything into this reference reference parameter can't pass in something invalid or something that's null. So typically, I will use references a lot for passing around large data objects, because the syntax is... You what?
Sorry, lag. I was just thinking, because obviously on line 5, as long as something's a pointer, it can be passed in.
Right, and you can cast anything.
You've got those, and sorry, I've just been, I've been doing all this terrain and stuff, and particularly when you start looking at voxels, which are, the amount of data required is ridiculous.
Yeah, at that point you really have to be conscientious about how much data you pass between functions. People in the IRC and BuzzNet are doing, you should really do this, and I really should, but we're not talking about const yet, because const is probably, the idea of constness in the C++ programming language would probably take an entire lesson to explain, because it is very wonky and strange. So, we are not going to be talking about constness today.
Can I just point out, you said wonky.
I did.
It's just fantastic. That's great. Anyway, continue.
Okay, so... a lot of fun stuff we can do with references. You can do other fun stuff, like, for example, a common... well, actually, that example would require templates. But, again, I use it typically when doing things like this, where I want to be able to pass in a large data object, potentially large data object, into a function. I'll use a reference. Using pointers is still required, though. We need pointers for a lot of different reasons. And so it's not like references can completely replace pointers. So you'll see a combination of both being used. Now, stuff and things.
Okay.
So again, very, very, very straightforward concept. There's not a whole lot to talk about in regards to references. It does bring up an interesting thing, though. An interesting thing that actually does lead into the next thing I wanted to talk about today, which will be initialization lists. So, for example, let's say I have a class called Class A. And Class A had an int reference number. Or how about just string reference? I'll just do int reference. What is wrong with this code? Can anybody guess what is wrong with this code? Can anybody guess what rule I am invalidating right now? And I'm not going to hover over the squigglies.
There was a question about your previous code that came in before you get too far away from that.
Hold on.
I'm not saying you should put it back up on the screen, but I just wanted to point the question out whether it's still...
So if we call method print string 2 again with another string, variable bool can be changed. I'm not sure I understand.
Would variable bleb, well, would variable bleb be changed?
No.
Assuming you passed bleb in.
Right. Well, you can change ble inside of that function, and that change will be reflected in main because, well, you're passing by a reference. As far as using references versus pointers, it's one of those things. If you can get away with using a reference, typically use a reference. If you can't get away with using a reference, use a pointer. It's really simple. It's not a super advanced, ridiculously complicated feature of C++, but it is nice. It does lead to some nice syntax.
See, no one's stepping forward in BuzzNet on this one.
Yeah, so what's wrong with this code? Come on. What rule am I breaking? What law am I
Wolf
violating?
Knightley, you're understanding everything so far. Tell us, give us an answer. That'll teach you. You give me questions. I'm understanding it all.
Actually, everybody. Yeah. I'm breaking the rule that when I initialize class A with the default constructor, what's going on is that our number is not referencing anything, which is breaking the rule of references. References may only reference one thing during their entire existence. So this is a very problematic code. Well, how do I fix it? Well, you might think that, okay, well, a logical way to fix this would be to have a constructor that takes in an int reference, and it assigns the reference to what we passed in. This is also problematic. Let me go ahead and fix the call site down here. This also causes a problem, and here's why. In C++, before the constructor is invoked, C++ will initialize all of your fields to their default values. But as we know, references do not have default values. It's impossible for a reference to have a default value.
Is that why the squirrelies occurs exactly where it does?
Yeah, it says
It's
provides no initializer for number, is what it should say. I don't know why it's cut off. So what we have to do is C++ introduced a new bit of syntax that allows us to actually change the behavior of C++ when it goes to initialize your fields. We can provide field initializers, but not in a way that you'd think in terms of C#. These are called initialization lists. And what they do is instead of the C++ compiler assigning our fields to default values, we can change what values they get assigned to. And we can do that in the context of a constructor, meaning we can assign values to our fields with the parameters that are provided to us by the constructor. Here's what the syntax looks like. Now the code compiles. And the instance of CLS1 will always be referencing the number.
okay. I think it's time to show off your elite whiteboard skills and show us what the logic is, what happens in what order in this.
I'll try.
I thought I'd get in there and ask before anyone else did. But it is quite
Well, yeah, so
we're into the realms of number, colon number equals number.
hello, Mr. Tablet. There you are.
It said hello back. Plonk.
You're welcome, Wolf.
Okay, so when I do this, M.
Wow.
Now, we can't make fun of him as he's actually making an effort.
We can.
Well, we can, but we're going to scare them off. We can't do that.
Oh, it's C. I couldn't, yeah. Class 1 something or other number.
Okay, this program, when this line of code is executed, the following things happen. The first thing that happens are the initializers. The initializers will initialize all of the fields. Remember, class 1 is defined like this. Which means that when this code executes, here's what happens. Let me go ahead and draw out the constructor as well. I think I'm getting a little bit out of practice.
That's easily fixed. Well, through rather more whiteboarding or electricity. Either way, easily fixed. Just saying.
Oh, no, I've got this vision of Nelson as Robocop for some reason. Shift M. There we go.
Wow, this is...
He still hasn't been practicing his ampersands either.
Okay, so when we do class 1 number, the first thing that happens are the fields get initialized. So all of the fields in class 1 get initialized. After these get initialized, the constructor gets invoked. Now, what do I mean when I say the fields get initialized? They all get set to their default values, which gives us a nice little paradox. Because you cannot initialize a reference to a default value, because a reference, by definition, has none. A reference must always be pointing to something valid. So what we can do instead is we can change this behavior, the initialization of this number, by providing this. This bit of code goes in and replaces what gets invoked before the constructor. So now what happens now what happens, now that we have our field initializer up and written, is when we instantiate class 1, the first thing that happens is this. Instead of going to the default initialization, it goes to our custom initialization. And then after our custom initialization, execution jumps into the constructor. There's actually two important implications of this, and I'll talk about the second one in a moment. Initialization lists are required for constant values, and again, their constantness in C++ is nothing like constantness in C#, and we will be covering constantness later. But they're required for setting const values, and they're also required for setting references. There's no other way to set a field that is a reference or a constant value without an initialization list.
And, yeah, there's a question.
Yeah, underscore numbers number is code that translates into this. This is just the syntax, more or less. I just ended up erasing like everything.
You could go back to the code now.
Oh, I have an undo key, don't I? Underscore number is a reference to this field. This is saying we want to initialize this field, underscore number, which points to this, which is a reference, or is, not to get the terminology confused, but underscore number is underscore number that we defined as a field. The number bit is the parameter that we passed into the constructor. this code roughly gets translated into, so basically, turns into it's just a different way to express the same syntax.
It's like a constructor for the constructor, really.
Yeah, it precedes the constructor. It's required. It sets the things up that need to be set up before the constructor can even execute.
It does have that ring of somewhat crowbarred, oops, we better find a way to do that about it.
Yeah.
It's kind of, oh no, we've programmed this in such a way that
It's impossible.
It's impossible.
There's actually another instance that I'll talk about in a moment as well, that these are required.
I was going to ask, could you show us it back in code with more than one argument for the constructor?
Yeah, and I'll also demonstrate another case that these are required for as well. Let's say we have a class B. Class B has one constructor. The one constructor to class B takes an int parameter, meaning the only way to initialize a class B is to provide an int parameter.
Wolf, no, the number in main is not relevant. Number on line 20, they're both the same. No, on line 20 are both the same thing, and underscore number, which is now underscore my field. Okay, I'm going to stop. It's not how you spell field either, but hey.
Why do you have to make my life so difficult, Gavin?
It wasn't me, it was Samuel
It's
Johnson.
called Samuel Jackson's in our class. That's awesome.
Samuel Johnson.
Oh, okay, my bad. I thought I heard Jackson.
No, the dictionary guy.
Could you imagine how awesome it would be to have Samuel Jackson in our class right now?
Oh, I thought you said, could you imagine how awesome it would be to have had Samuel L. Jackson as the guy writing the dictionary?
Well, that would be awesome too.
Coming soon to cinema.
That would be the most awesome dictionary ever.
Sausage. Right. Obscure references.
Okay. Initialization lists allow you to initialize fields that cannot be initialized using the default C++ initializer. This is for reference fields that are references, as well as fields that are non-pointers to objects that only have a constructor that takes parameters. For example, ignore, and people who are getting lost right now, hopefully this example will help a little bit, ignore the fact that we're using references right here, right now. Just concentrate on class B other object. In fact, if I just went ahead and nuked out this code temporarily, if we try to compile this, of course we get a success. If we try to compile this, look at what we get. We get an exception. We get a compiler error. Why do you think we get a compiler error here?
Whim.
We get a compiler error because we have a field that is of type class B. Class B requires that we pass in an integer into it. There's no way to create a class B without providing an integer into the constructor. So there's no way for us to be able to instantiate a class B with the default initializer. Remember, initializers run before the constructor. So we need a way to override C++ and tell it, no, we want you to initialize this field this particular way. So before I get too far into this example, I'm going to bring back the references stuff. Okay, so now we have this Class B field. This Class B field cannot be initialized by default because the only way to initialize is to provide an integer. And there's no way for the C++ compiler to guess what integer to pass into the constructor of Class B because that doesn't make any sense. So what we do is we use initialization lists. So by providing a comma followed by other object, I can pass in my integer. And let's say we want 10.
And presumably this can be one to many. You can another comma, another pointer.
Yep.
Another. This could be two of the same thing. This is not specific. There's no specific order that you have to go through like there is with inheritance and initialization in C#.
Yep. All right. Are people feeling good about this? Okay, you guys ready for another quiz that, of course, Segfault's not allowed to answer?
We can have naughty class.
Yes.
Oh, and Craig, I like that XKCD. We could use that as a prerequisite. If you understand why that's funny, you're allowed. You know enough to do this class.
I actually reference that so often in code. It's fun. Derp. Okay. So why is good class better than bad class? Other than the name?
It's upbringing.
Anybody?
Bueller.
Because in this case, both good class and bad class compile. Okay. The reason why this class is better than this class is that in this class, when I do bad class CLS low, what happens is the string gets initialized to its default value, and then it gets copied or gets assigned to another string. So these are two operations. The first one is the string class gets initialized. The second one is that it gets assigned to. The good class, however, passes in what would inevitably be assigned to it via the constructor. And as a result, the good class will be slightly more performant. And and string in particular isn't a particularly heavy class or a class that's going to cause any huge performance issues. But in the case where you do have a class that has a very relatively unperformant constructor, you want to make that constructor invocation count. You don't want to invoke the constructor of an object and then assign it to something else later. You would rather, by copying the data, you would rather just pass in the data you want the field to be into the constructor itself.
Yeah, Jeff, I think he said it will compile.
Yes.
Yeah.
The difference is the initialization list. Good class is using initialization list, bad class is not. Bad class is doing an assignment. This is the syntax. It's not a it doesn't look that different to me situation. This is different because the C++ specification says that it is. Yeah, exactly what Atomizer said. Both classes will work just fine, but one will be slightly more performant, and one is considered to be the right way, and I'm finger quoting, to do things in C++.
be reading questions.
No, the class A with class B as a field example didn't compile. Well, it did when I fixed it. Here, let me go ahead and... I have so many notepad windows open. Give me another one. Where are you? Oh, really? You're doing this to me? Hold on.
Right now,
Yeah.
in front of all of
I
these
know,
people.
my VM is eating.
Come on.
Is eating my windows.
It's hungry. VM's got to eat too, man.
Get your coat, we're leaving. What have you made to look a fool of?
No, this code compiles now because I added this bit to it, to the initialization list. Otherwise, if I did not have this on the initialization list, then, well, we get an error.
And Wolfnightly said, why is it less performant for the bad class? Well, the bad class is you're doing two operations. First of all, you're setting string to null, presumably.
No, empty string specifically, and it will be doing a lot of not a lot of operations. It's just a rule of thumb. I just pick string.
Doing something.
Yeah, it's going to do something.
And then you're changing that immediately afterwards. It would be like saying int n equals 10, and then on the next line saying n equals 20. That's less performant than saying int n equals 20 and being done with it. And similarly with the initialization syntax, there isn't a line that says string equals string inside of the constructor. It's already been done. You never set it to
right.
Empty string
You're constructing
first.
it with the data that you want in it initially. But why did you get an error with that but not with the string? The reason I'm not getting an error by not providing an initialization list for the string is that a string has a default constructor. It has a constructor that takes no parameters. If a type has a constructor that takes no parameters, C# will generate the field initializer to simply invoke the constructor. So there's no requirement that we provide an initialization list for it. You what?
Did you cover Stephen's question?
Stevie's?
Stephen's question, or the one that hasn't got a red flag?
So the values passed in the initialization list have to either be literal values or values passed into the class constructor. Well, not necessarily. Typically, you will, but you can also provide expressions. So as an example here, we provided some actual executable C++ code into this if we wanted to. However, you would typically, what you pass into an initialization list should generally be either a constant or a parameter, because and that will generally be what it won't be very often when you want to initialize something to something that isn't computable from a parameter, a constant value, or a simple expression. What's a constructor? I hope that was a joke. So it is done. It means set once the good class and is being set every time you make a new instance of that class. Well, yeah, every time we make an instance of either good class or bad class, string will be eventually assigned to whatever you passed into the constructor of good class or bad class. But with bad class, two things happen. This gets set to its default value, and code actually runs, the constructor runs, and then we tell it to contain other data. Whereas with this, when we create it, we tell it exactly what data we want it to contain. That's the only difference. Because remember, for every field that you see in C++, remember that whenever you construct a type that contains this field, C++ will run code to initialize this field to something. The only way to override what C++ comes up with to initialize your field with something is to use this syntax.
Have you got something lined up they could perhaps code up themselves to rub this in?
No.
Yeah, there's this.
Other
Yeah, do Quake 6.
Quick 6.
Okay, yeah, Quake 6. We'll just skip right over 5. It won't take you guys long. Get to it. Snap, snap.
Click 6.
It's right over your head, Nelson. Zoom.
I don't.
And yours. Segfault got it.
Oh, Quake! I thought you said click.
I did not say click. Everybody in the darn
I heard
Buzznuts
click.
even got it.
Because, I mean, even I've heard of Quake.
Wow. Everybody at Buzznet gets it, and you two are just like, duh. So tonight's class is brought to you by...
The letter, duh.
Yeah, about the letter duh. All right, go ahead. I'll just be quiet.
Okay, so
I did not say click. There's been plenty of people that have already heard what I said. Quake, people, quake.
all right, we did get one last question. I'm about to head off to break because we're just about done with the initialization list and references. Any questions that you guys have about initialization list or references, be sure to post in the questions panel. The rest of the class is going to be spent coding a lot of stuff. So get prepared to code a lot of stuff. There is one last question that we'll answer before break. So is it better to use initializers for all of your class members, even things like int, float, etc.? Yes. In those cases, the only reason why it's better is for consistency. But the essentially, it is just a matter of if you can use a field initializer, use a field initializer. If you have to use a field if you can use initialization list, use initialization list. If you have to use initialization list, well, you have no choice. If you can't use an initialization list, well, it's not the end of the world. And that's basically the rules. Alrighty, so I'm going to go ahead and pause the video.
And as the video is now getting paused.
And we're back. So yeah, we're basically going to be coding up some code. Everybody who wants to go ahead and follow along, go ahead and hit the participate button in BuzzNet. I'm going to reset everybody's ready. I do want to point out, and I'm going to reset everybody's ready again, because I know you're not ready. I'm going to reset, and I'm going to do it again, and you will lose this game. I guarantee you. Okay, so, yeah, basically, what we're about to code up is going to be something that will be necessary for you guys to have coded for the homework, because the homework is going to be finishing this application. So, yeah. Let's go ahead and write some code. Okay, so what we're going to be putting together is a basic Tic-Tac-Toe game, or more or less a basic Tic-Tac-Toe game framework thing sort of stuff. And it's going to be using a lot of the things that we've been talking about in 101 and 102. So if you guys have any questions about what we're using, now's the time to ask them. And again, it's a good way to gauge people's sort of level at the moment. So we're going to start off with a few different type stubs. We're going to start off with a board square enumeration. We're going to have a class called board with the following public members.
So why are you putting an enum called E inside of a struct called board square rather than...
Because remember that enums do not, their values do not, aren't constrained to any scope. Meaning if I had enum E if I named that enum board square and I had it outside of a structure, X, O, and empty would appear in the global scope. It wouldn't be board square : X, it would just be X. So by placing it inside of a structure and having an enum called E, we can now qualify the different enum values with some sort of scope.
Could you not put it in a namespace?
I could, but I wouldn't want to.
Well, I said what asked. I was just passing it on. But why wouldn't you want to?
Why what?
Why wouldn't you want to?
It doesn't feel right.
That's fine if that's, you know, as always, if that's why, that's fine. But explain your reasoning, don't just go.
Alrighty, so these are the stubs for the 3 types or 4 types that we're going to be putting together. And we're going to be filling out all the private members as well as the constructors here in a moment.
Are you intending to keep them all in the one CPP?
Yes. So go ahead and hit ready once you have this code typed out, 1 minute if you're still working on it, and so on. Type faster.
Could you just move your cursor a touch, please?
I don't know if I should pause the video or what I should do with this.
Yeah, you should probably pause the video first, just letting people type.
Okay, and we're back. So let's go ahead and fill out our board. What's our board going to do? Well, it's just going to basically be a wrapper for, for data. So let's go ahead and fill out his private members. Int width and board square e pointer squares. The constructor to board will take in a width, assign it to his local width using the initialization list, and then instantiate an array of board squares by saying squares equals new board square e width times width. Then we're going to loop through all of the indices within the board squares and set them to empty.
Just double checking because you said new on line 24, but didn't.
I don't know what you're talking about. Okay, so the width.
I actually assumed it was the other way around. I thought you'd sort of were saying the implication.
Okay, so get width is simply going to return width. Get total board squares is going to return width squared. Get square is going to return squares at index. And I can break that out a little bit. And then set square is going to set a square at index. Finally, we need a nice little destructor, as nobody has pointed out at this point. I'm very disappointed. To clean up our squares. So here's the full board class that represents a basic wrapper around a array of squares. So I'm going to go ahead and hit pause. And we're back. We did get a few questions. What are the limitations of auto? Is it as versatile as var and C#? It behaves exactly similarly to var and C#. It is simply implicit typing. Can you explain what data type board square e pointer squares is exactly? Well, the data type of this field is a pointer, but when I'm instantiating it as an array. So it is a dynamically instantiated array that I reference by using a pointer. So this is a pointer to board square e.
I think I speak for many when I say, huh? It's a pointer.
Yes.
See, I was wondering about it. It's a pointer, and yet you're just directly instantiating it as an array.
Mm-hmm.
Okay.
that's what's going on. When working with dynamically instantiated arrays, you typically will have to use pointers to reference them. Yeah, like Musaru says, arrays are pointers. I don't get the iRule engine in public where you have virtual. What are you doing with the equals 0 part? The equals 0 part means that this is a pure virtual member, or a pure virtual function method rather, and another word for pure virtual is abstract, meaning it has no implementation. And by having a pure virtual method within this class, it makes the class abstract. In C#, struct.equals compares the values contained in the struct, whereas class.equals checks the actual objects are the same objects. It's the same true for C++. Oh, well, that's a question about value types versus reference types, I think. When comparing in C++, there is no concept of a value type or a reference type. In C++, you just have types. Now, you can have a pointer type to anything, and you can have a reference type to anything. In C#, however, a value type will behave like a value type because it's a struct or an enum, whereas a reference type will behave like a reference type because it's a class or an interface or a delegate. In C++, you don't decide if something is a value type or a reference type. When you construct the type or define the type, you decide whether or not you want it to be a value type or a reference type in the way you use it. So in C++, the answer is more complicated. If you compare two board pointers to each other, that will check to see if they're the same object. If you compare two board non-pointer objects to each other, you'll get an error unless you implement the equality operator, but if you do implement the equality operator, that will most likely return true if they have the same members within them. Why not just board squares, though? Because the E type is what I want. Remember, this structure contains an enum. The E type is what I want. I don't want board square. I want the E underneath board square. A class with all pure virtual methods is an interface, right? Yes. That's not... I mean, it is a very common moniker used for classes that have all virtual methods. If a class only has pure virtual methods, it has no non-pure virtual methods, and it has no fields, then it is appropriate to refer to it as an interface. And as you'll notice, I did actually prefix this type with the I prefix, which indicates that it is an interface, at least per convention. What does the equal 0 mean? How are you doing that to a method? Again, this is just syntax. It's ridiculous syntax in my opinion, but it's just syntax. That's all it is. This is how it is. That you're not setting anything. This isn't the assignment operator. This is just the magical bit of incantation you use in C++ to indicate that it's an abstract method. It's not doing anything. It's not doing an assignment. You're not assigning has 1 to 0. You are saying it is an abstract method. And that's just a bit of the syntax. When I highlight it says error, identifier get total squares is undefined. Make sure that you have a get total squares method implemented. Notice how I have one implemented on line 35. And make sure that your spelling is correct.
And make sure that everything is in the same order.
Well, in the classes, the order doesn't matter.
Okay.
Yeah. Don't you love C++?
I was trying to be helpful, and it turns out it's not necessary. Well, you could flick onto the screen.
Okay. I can jump on your screen, Tyler, if you want.
You said sure.
Blah 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 blah.
I will actually. I'll talk about this because this is something we do. If we do flick to your screen, you become a presenter. When you are no longer a presenter again, due to the way the webinar works, your questions, your panel will switch itself over to another option. So if we make you a presenter. And afterwards we don't seem to be answering your questions, check that you are sending questions to staff, because you may not be. Hello, Tyler.
Hello.
Hey.
Hey.
Hi.
Ooh, radio voice.
Ooh, you have a syntax error. Oh, wait a sec. First of all, if you're going to swap over to
And one here.
If we're going to swap over to your screen, could you go ahead and turn on line numbers, please? Because
yeah.
otherwise it'll be very difficult for us to...
Super fast, remind me how to turn them back on.
Tools?
Where'd they go? Tools.
Options.
No.
Text editor. Text. Yep. Expand that. Jump into all languages and just click on all languages actually, and say line numbers under display.
Oh, well, that's obvious.
Yeah, I know. But the problem. This is the funny thing about C++. I can.
The one funny thing?
Yeah. I can see what is actually going on right now. You have a syntax error in line 34, which is preventing C++ from parsing the existence of get total squares on line 35.
Okay.
So it doesn't think get total squares exist because of the syntax error in line 34. Now, if you look closely at the difference between line 35 and line 34, can you guess as to what that syntax error might be?
Could this be it? Oh, wait. Oh, new errors.
Sweet. And then you have an extra E on that one.
Well, yeah.
Sure I do.
Yeah, that is exemplary
Oh, the text
of
is gone.
that is exemplary of the sort of problems you have with C++ that you tend to have fewer of with C#.
Yeah.
You get an error that says one thing and actually means something else. It's just misinterpreting.
Yeah, and you'll get that a lot where one bit of code on one part of one class will prevent it from correctly parsing another bit of code that could be on an entirely different file, and then you will be running around in circles for hours. So just, yeah. But yeah, so that was that. So cool. We got to showcase some of the fun debugging that people will have to do. Okay. Still hung up on the enum. So you create a struct that contains data and actually grab the data inside it without making the actual version of the struct itself. I'm never instantiating the struct. The only reason I have it here is for organizational purposes only. I never instantiate a board square. This is just a convention that I use to clean up the global namespace. It's nothing more than that. I don't use the struct board square. I only use board square at E, or board square E. E scoped to board square.
I'm glad it wasn't just me that found that confusing, because I did.
Can you go over what the initializer on line 21? Yeah, the initializer on line 22 is simply assigning the width field to the width parameter that's passed into board. Okay, so moving on, let's go ahead and jump down to something. We're not going to... rule engine is already implemented because it's just an abstract type. Let's go ahead and implement game. Now, game is going to be fun to write. Game is going to have two fields. It's going to have a board reference and an iRule engine reference. It's then going to have a constructor that takes in a board reference and an iRule engine reference. Then it's going to use the initialization list to initialize board to board and rule engine to rule engine. Okay, so I'm going to go ahead and expand run temporarily. We're going to fill out run in a moment. I'm going to stub out a few more methods. I want a method called render for, well, rendering the board. And then I want a nice little method called get square car or get squared char.
Thank you.
Like that. So to implement the get square character method first, it's going to be very straightforward. Switch on square, case board square x, return x, case board square O, return O. And finally, return index plus 0 otherwise. So what this is saying is, for a given index, print out x or O if they're x or O, or print out the index of the square. Now remember, the index is coming in as an integer, but keep in mind that to convert an integer to a character, to get this to be represented as 1 through 9, as a character 1 through 9, we add it to this. Now I know this looks kind of funky, but what we get back is index can be anything from 0 or 1 to 9, but what we get back is the character 1 through 9. So by adding index to the character literal, we put that index value into the range of the ASCII values to represent the ASCII 0 through 9.
Because the ASCII for 0 is 48.
Right. I could do index plus 48.
And the ASCII, and it goes up like that. The ASCII for 1 is 49, and so forth. So essentially, yes, you're doing the sum behind the scenes.
What if the array has more than 9 elements? Good question. Then you would change your get square character method. I'm just keeping things simple. I did want to purposefully make the board any size possible so that people will have to really think when implementing the rule engine. But to get it to render properly, you're going to have to do some more fun stuff as well. Okay, so the render method is going to be very straightforward. For auto I equals 1, I smaller equal to board dot get total squares. Notice something interesting about how I access members of references. Although board is indeed a reference, I'm accessing the members of the reference via the member resolution operator, the dot operator. I'm not accessing it through the traditional member resolution dereferencing operator, the arrow, because board is not a pointer, although it is similar to a pointer. Then we're simply going to say cout get square character I, and then board dot get square at I minus 1. I'll talk about that in a second. And then add some white space, and then I'm going to say if I modulus board get width equals 0, cout new line. Okay, so what I want to do is I want to loop from 1, because I want the UI that I didn't really talk about the UI. The UI I want to be very simple. Every single item in the Tic-Tac-Toe board is going to be represented with the numbers 1 through 9, at least for a 3x3 board. And so when I print it out, I want to print out the numbers 1 through 9. But when I actually get the square out of the board, I need to subtract 1 because the indices are actually indexed, are 0 index based, even though the user interface is going to be 1 index based.
And these sorts of -1 here and +1 there and less than or equal to are, they will either you'll get a grip of them, or they will make your life hell, or quite possibly both. There's an awful lot of this when you come down to dealing with things, and particularly in terms of user interface, because we're programmed to think in terms of starting with 1.
Well, society programs us that way.
Yeah,
Programmers
exactly.
are programmed to think differently.
Exactly, and somewhere you'll often find yourself having to offset by 1 just to make users not moan at you.
I actually have a joke about this. Do you want to hear the joke?
A joke?
Yeah, a joke.
Is it a funny joke?
It is a funny joke. It's off by 2 errors are really obnoxious. You get it? You get it? Come on, anybody? Oh, sorry.
Yes.
Okay, so let's go ahead and implement our run method.
Yeah, tumbleweed. Yes.
Okay, so our run method is actually going to go ahead and run our code. The run method is only going to probably fit on 1 screen of code. So what I'm going to go ahead and do is I'm going to reset everybody's ready. Go ahead and type out the render and get square character, as well as the private members and the initialization.
Are you going to pause while they do?
Yeah, and we're back. And it sounds like Gavin's back too. Let's go ahead and implement our run. Our run's going to be very, very straightforward. So we have two enumeration variables, winning player and current player. And then we'll say while winning player equals rule engine has one board equals board square empty. Then go ahead and render, print out a new line, get our input, print out move for get square character. I know I'm reusing a function when I really shouldn't be, but it's my prerogative. Grab in the input, do a cin.ignore, and then go ahead and do input minus equals 1. Remember, we want to convert the user input into a list of valid indices to our board. So then I'm going to say if input is smaller than 0, or input is greater than board.getTotalSquares, or board.getSquare at input does not equal board_square.empty, then cout invalid move and continue. Otherwise, set the square at the input index that was passed in to the current player, and then set the current player to equal current player equals board square x board square o board square x, and then once this method is done, we'll return winning player.
This is going to be a fun explanation.
Well, it's just straightforward.
Strap in, people.
Okay, so we start off defining two variables, winning player and current player. We set current player to x. We say while winning player equals rule engine has won. So this is where the rule engine has the opportunity to say that a certain player has won. And while that equals board square empty, so while the rule engine has indicated that no one has won, render the board, hit a new line, get the input. So everything up to here is just straightforward code. Then we say input minus equals 1 because we want to translate the 1 index-based user interface into the 0 index-based used by our board. Then we'll say if the input is out of range, so if it's smaller than 0 or greater than the total squares of the board, or the board currently has something on that square that isn't empty, then print out invalid move and continue on. Finally, we set the square that was indicated by input to the current player, and then we swap the current player. We say if the current player equals x, then set the current player to O. Otherwise, set the current player to x. So I'm going to go ahead and reset everybody's ready. Go ahead and hit ready if you are ready, 1 minute if you're still typing, and we're going to pop. All right, and we're back. I'm going to go ahead and make a quick change, and I'm actually making this change for two reasons. One is because it's bad design, and two because
I can moan that.
well, two because I realized the bug in the code doesn't allow for stalemates. So let's go ahead and do that. I'm going to create another enum called
Player.
winner. Or how about just player? Enum E XO stalemate and none. And I'm actually going to call this winner instead, or winning player. Okay, so the winning player enum, go ahead and get that typed out. It's just a winning player enum with XO stalemate and none. Those should be fairly obvious as to what they do. So, to use the struct, I'm going to change the rule engine class to return a winning player. And I'm going to change the method name to get winning player. You don't have to go ahead and do that, but again, I just typed this code out too fast, too quickly. So the rule engine becomes winning player E get winning player board. Now, the final few differences is that run will return a winning player. And then the winning player variable will become a winning player, while the current player will be set to a winning player as well. So actually both of them will be winning players. But we're only using that for internal use. So then winning player equals rule engine.getWinningPlayer. while it equals winning player none, continue to do stuff. The get square character will actually change into a small little ternary, which will be current player equals winning player X, X, or O. And of course, because of order of operations, we have to surround that in parentheses. And then the set square will be current player equals winning player X, board square X, otherwise board square O. And then the current player will be that, and that. And we get compilation. So, again, all we did was we added this enum up here. I'm going to go ahead and, I don't know, split the screen or something. So we have that additional enum being defined. We changed the signature of the rule engine to return a winning player. I changed the name, you don't necessarily have to. And then run became this. The biggest changes are here, 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 and here. Or, sorry, here. Those are all the changes that had to be made because Gavin really doesn't like the way it's set up. And also this will account for stalemates. So pausing the video, zoom the video, and we're back. We have one last bit of code to write, one last class to write. This is the class that you guys are going to be filling up. I'm going to call it Null Rule Engine, and I'm going to have it inherit from iRuleEngine. And it's going to implement the getWinningPlayer method. And it's simply going to return winning player none. That's it. So now to see how we can use this code, let's go ahead and create a board with the width of 3. Then let's create a rule engine, a null rule engine. Then let's create a game, tie up the board with the rule engine, and then let's just invoke game.run. And if you run this code, let me verify that this actually works. We have a basic framework for building Tic-Tac-Toe.
There appears, however, to be a small problem with our rule engine.
Yes, a lack of...
Doesn't work.
A lack of
any sort of rules or engine-ness about it.
Later, Segfault.
Well, Segfault, for your sake, that's what the homework is. You now know.
All right. So I'm going to pause again. And we're back. So what we have here is a basic stub for a basic tic-tac-toe game. What you have left to implement right here is the get winning player. Be sure to implement your get winning player in terms of a board of any arbitrary size. That's very important. You can access that by doing board.getWidth or getTotalSquares. So your challenge is to create an algorithm that determines if a particular player has won or if there has been a stalemate. So that's really about it for this class. Is there anything you wanted to add, Jason or Gavin?
I would just like to precede any threads that may well appear by saying that Google and Wikipedia are your friends. Use them. Tic-Tac-Toe is one of the most mathematically completely studied things. It's, you know, everything has been done to it. You can work it out. Somewhere you'll find the relevant stuff if you are unsure of sort of logically what needs doing.
Yeah. Okay, and again, if you want to submit homework, which you should want to do, be sure to read the sticky in the Member Sponsor Lounge for the homework submission steps, and this will be linked once the homework is posted. Send your Dropbox information to Gavin Whitlock via PM.
FatGav via PM. Click on my name there, and you will get a send me PM window will come up. You'll need Dropbox. Follow the instructions. Please, please. I've said this every time. I still get people who can't seem to follow basic English instructions. Type what I tell you to type there. The subject line. Dropbox account : C++102. In the body, put the email that you use for Dropbox. That's all. If you don't do that, the batch program that I use to go through these won't find you. And then you'll be sending me more PMs saying, why haven't I got a Dropbox set up? And I'll be sending you PMs saying, because you didn't follow the instructions you were given. I am rapidly losing patience, as you'll have gathered.
Clearly, Gavin is not better at this at all.
No, not at all. I mean, we made it as simple as we possibly could, and it's really starting to irritate me. Anyhow, yeah, just follow the instructions in here, and you'll be gone. There is a link to Dropbox there as well. If you don't know what Dropbox is, welcome to the 21st century. And yeah, there will be a thread for this week's homework specifically, which you'll be able to get out via the live classes calendar. And I don't know that there's anything. Yeah, check that thread for the deadlines for homework submission, which will be the beginning of next class, and for the Dropbox submission, which will be sometime before that, usually a couple of days before that, but it just depends on exactly when I decide would be most convenient. That's all the usual, I think.
Alrighty. So I hope everybody enjoyed the class, and we're signing off.
Goodbye, future people.
Bye, future people.
Goodbye, future people.